Bismillahirrahmanirrahim. Assalamu alaikum, dear students. How are you? I hope you'll be fine. This is Cambridge Lower Secondary Book 8, and today we are going to do question number 12 and onwards of exercise 1.3. We are already done with the previous question. So watch the video till the end, do not skip the video. And if you like the video, please do subscribe to my channel and share it with your friends as much as you can. Now, in question number 12, we are provided with some of the values of x and the expressions are given along with that. So let's try to solve this one and try to complete this table. If x is equals to 2, x minus 1 is given. Over here would be 2 minus 1 is equals to 1. It's already been done. And then x cube minus 1 would be 2 cube minus 1, which is 8 minus 1 is equals to 7. It's already done over here as well. And then the third equation is x square plus x plus 1. So x square would be 2 square plus 2 plus 1. That is 2 square is 4. 4 plus 2 is 6. 6 plus 1 is 7. Now let's move to the next part. Here we have x is equals to 3. So if x is equals to 3, x minus 1 is equals to 3 minus 1 is equals to 2. It's already been given. And then x cube minus 1 would be 3 cube minus 1. The cube of 3 is 27. 3 3s are 9, 9 3s are 27. Here comes 27 minus 1 is equals to 26 in the second column, and in the third column we are already provided with the value of x squared plus x plus 1 as 13. Here comes the third part. So in the third part you will find that x is equals to 4. So x minus 1 would be 4 minus 1 is equals to 3. So in the first column we are getting 1 2 3. This is the pattern followed up till now. And then x cube minus 1 would be, then let's see, it would be x cube minus 1 is equals to 4 cube minus 1, that is 4 4s are 16, 16 4s are 64, minus 1 is equals to 63. So this is 63 over here. And I guess in the third column it would be 21 if I'm not wrong. Let me see. Let's see if we get 21 or not. If we will get 21, then the pattern is followed. Over here is the first column getting multiplied with the third column gives us the answer to the second column. Okay, let's see. So it's like it's x square plus x plus 1. Here is x square is 4 square plus 4 plus 1. The square of 4 is 16. 16 plus 4 is 20. 20 plus 1 is 21. Oh, wow. It means I got what is the pattern out there. We have to find what pattern can you see in your answers. So students, if you look at the first column, here 1, and the third column, and you multiply these two, the answer would be there in the second column, you see. Similarly, if you multiply 2 with 13, you will get the answer 26, which it's there in the second column. Yes. Similarly, if you multiply 3 with 21, it would be 63 in the second column. You see, this is the pattern being followed over here. So in fifth one, it would be if x is equals to 5, x minus 1 is equals to 4. Fine. And then if x cube minus 1 would be 5 cube minus 1, which is 125 minus 1, that is 124. If it's 124, we can figure out that what would be the answer to column number 3 without even solving, because 4 times third column is equals to 124. So 124 divided by 4 is equals to 31. Here comes 31. And now if you will solve it, you will find that that's the answer to column number 4 for this part. You see, if we have x square plus x plus 1 as 5 square plus 5 plus 1, so it would be 25 plus 5 plus 1 equals to 31, you see. Now we have to add another row to see if the pattern is still the same or not. Okay, yes, let's add one more over here. Let's take 6, you see, and then the x minus 1 would be 5. X minus 1 equals to 5. X cube minus 1 would be 6 cube minus 1 equals to 216 minus 1 is equals to 215. And when we will divide 215 by 5, it gives us 5 fours are 20, 5 threes are, so it would be 43. Let's check it out. X square plus x plus 1 is equals to 6 square plus 6 plus 1. Is it 43? So 6 square is 36. 36 plus 7 is equals to 43. Okay, yes, the pattern is still the same. Now we have to add 3 rows where x is a negative number. So now we have to take x as the negative number and check it out that are we getting the same answers or not. Let's take x as minus 2, okay, minus 3 and minus 4. So in case we have x is minus 2, x minus 1 would be minus 2 minus 1, that is minus 3. It would be minus 3 minus 1 is equals to minus 4. It would be minus 4 minus 1 is equals to minus 5. So the answers to first column x minus 1 would be minus 3 minus 4 minus 5. Now let's move to the next column, that is x cube minus 1. If we have x cube minus 1, minus 2 to the whole cube minus 1 would be minus 8 minus 1 is equals to minus 9. Here comes minus 3 cube minus 1. So the cube of minus 3 is minus 27. Minus 27 minus 1 is minus 28. Okay. And for the third one, we have minus 4 to the whole cube, which is minus 64 minus 1 is equals to minus 65. So if the pattern is followed, so according to the rule, we have to divide the answers minus 9, minus 28, minus 65 with minus 3, minus 4 and minus 5. So the answers to the third column would be minus 9 divided by minus 3 is 3 and minus 28 divided by minus 4 is 7 and minus 65 divided by 5 is 13. It means the answers to the third column must be positive and they must be 3, 7 and 13 in the row. X square plus x plus 1. Let's check it out. Here we have x square, which was the value of x was minus 2. So it would be minus 2 to the whole square plus minus 2 plus 1. Here we have minus 3 to the whole square plus minus 3 plus 1. Here we have minus 4 to the whole square plus minus 4 plus 1. So in the first one, it's gonna be 4 minus 2 plus 1. Here it's 9 minus 3 plus 1. Here it's 16 minus 4 plus 1. So ultimately it's 4 minus 2 is 2, 2 plus 1 is 3. Wow! Then 9 minus 3 is 6, 6 plus 1 7. 16 minus 4, 12 plus 1, 13. Oh yes, the pattern is still followed in the negative numbers. Okay. So you just have to compare your answer to the pattern. Basically, students, let me tell you the secret behind that. It's an identity. And the identity you are going to learn in grade 9 or onwards, that if x cube minus 1 is equals to the product of x minus 1 into x square plus x plus 1. This is an identity we use in algebra. You're going to learn in grade 9 or so, right? Therefore, 1 multiplied by 7 was 7. Therefore, 2 multiplied by 13 was 26 and so on. You see? Now we have to learn a complete new concept of rational numbers. So basically, students, we have real numbers and non-real numbers. Real numbers includes all the rational numbers and irrational numbers. So let's learn what are rational numbers and what are irrational numbers. So rational numbers are basically the numbers that can be expressed as a fraction, a upon b, where the answer to this is not equals to 0. Okay? Acha. So what numbers are included in rational numbers? All the natural numbers, that is starting from 1, 2, 3, 4, and so on. All the whole numbers starting from 0, 1, 2, 3, and so on. And then all the integers, that is positive and negative numbers, okay, that have both positive numbers and negative ones. So all these numbers are rational numbers. And when we talk about the fractions, so all the fractions are also rational numbers, like 1 upon 2, 2 upon 5, 4 upon 9, 6 upon 8, or 6 upon 11. What else? All the fractions are rational numbers. But when we talk about decimals, some of the decimals are rational, but not all decimals are rational. There is a category of decimals that are irrational numbers. So what decimals are rational? The decimals which are either terminating. Let me explain what are terminating decimals. Like 0.1, 2.5, 6.345. These are called terminating decimals. Or if we have non-terminating decimals like that do not terminate at any point, but we have two categories in this one. Non-terminating decimals are the ones that keep on going, like 0.33333, 0.666666, okay, 1.252525, and so on. These type of decimals are called non-terminating, that do not stop at any point. Similarly, 16.243716015, and so on. Okay, so these are all the examples of non-terminating decimals. So some of the non-terminating decimals are recurring, that repeats themselves, like 0.33333. The digit 3 is repeating itself. 0.66666. It's a recurring decimal. 1.2525252525 are repeating themselves. So these are the examples of recurring decimals. But there is another category of non-recurring, non-terminating decimals. So this category is not included in rational numbers. Instead, it's an irrational number. Okay, so the category of irrational number includes all the decimals that are non-terminating, that do not terminate at any point, and they are non-recurring at the same time. Okay, so it includes all the non-perfect squares and all the non-perfect cubes, right? Non-perfect squares and non-perfect cubes are all irrational numbers, okay? So non-terminating, non-recurring examples are the value of pi, because when you will put this value pi in calculator, you will find that the value of pi is irrational. It's not rational, okay? If I could show you what is the value of pi. So the value of pi is equivalent to 3.14159 2653589799323. So you will find that none of the numbers are repeating itself. We have no pattern included in that. Therefore, this is an irrational number. Similarly, under root 2, under root 3, not under root 4. Under root 4, 4 is a perfect square. So all the square roots of a perfect square, the cube roots of perfect cubes are rational numbers. But the square roots of non-perfect square and the cube roots of non-perfect cubes are irrational number. Okay. Similarly, the cube root of 5. Similarly, the cube root of 9, cube root of 12, cube root of 100. These are all non-perfect squares and non-perfect cubes. Hence, they are all irrational numbers. Now, let's get back to the question we are provided with in question number 13. Any number that can be written as a fraction is a rational number. We already know that. Examples are 7 whole 3 upon 4, minus 12 whole 18 upon 25, 6, 1 upon 15, minus 2 whole 9 upon 10. Now they are providing us with a list of 6 numbers. They are saying to write all the integers in the list. What are the integers? Positive whole numbers, positive natural numbers, and the negative natural numbers are all the integers. So in this list, we have 5 as the positive integer, minus 500 a negative integer, 16 a positive integer, but minus 1 upon 5 is a fraction, it's not an integer. Minus 4.8 is a decimal number, it's not an integer. 19.9 whole 1 upon 2 is a fraction, it's not an integer. Now let's talk about the natural numbers. Natural numbers are only the positive integers. So in this category, we will only take the numbers from the integers list that are positive. So in this list, we will have only two numbers, that is 5 and 16. Not even minus 500 would be a natural number, because natural numbers starts from positive 1. Then comes the rational numbers. Since all of these numbers that are integers are rational numbers, so we will write minus 500, 5, 16. First of all these numbers, they are all rational numbers. Then minus 1 upon 5 is a fraction. It's a rational number. Minus 4.5 is a terminating decimal. It's a rational number. 99 whole 1 upon 2, it's a fraction, so it's a rational number. So all of these 6 numbers are rational numbers. Here comes question number 14, which says this Venn diagram shows the relationship between natural numbers and integers. So here we have a Venn diagram. You can find that here we have a circle, and outside this circle is written n. Means in this circle we have to write down all the natural numbers. Okay. Then we have a circle outside, and in this circle outside of n, that is outside of the n circle, we have to write down all the integers that are not natural numbers. Okay, so what are we gonna start from? We have to copy the Venn diagram. Okay, you people copy it down in your notebooks. Then in part B, you have to write each of these numbers in the correct part of the diagram. So first of all, we will choose all the natural numbers from the given list and write them down in the inscribed circle. So 1 is a natural number, minus 3 is not a natural number, negative numbers are not natural. Okay, then comes 7. Yes, 7 is also a natural number. Then comes 41. But minus 3, minus 12, minus 100 are all integers, but they are not natural numbers. So we will write down these numbers over here. Minus 3, minus 12, and minus 100. What does it mean? It means 1, minus 3, 7, minus 12, 41, minus 100 are all integers. And out of these integers, 1, 7 and 41 are natural numbers. What about 2 whole 1 upon 2? Can we put this number into the category of natural numbers? No, it's a fraction and fractions are not natural numbers. Then can we keep it outside the inner circle that is inscribed in integers? No, we cannot write it inside the circle anymore. So we have to write it outside over here because it's not an integer nor a natural number. Okay, so what do we have to do in part C? They are saying add another circle to your Venn diagram to show the rational numbers. So we will simply make a circle out there and we will write 2 whole 1 upon 2 in this circle, and we will write R over here. That is, inside this circle, all of the numbers are rational. We have already learned that all the natural numbers are rational, all the integers are rational, all the fractions are rational numbers. Now we have to add these numbers to the Venn diagram. Okay, minus 8 whole 3 upon 7, it will come over here. It's a fraction, so it's a rational number. 3 upon 5, 3 upon 5 is again a fraction, so it will come over here. Then 0. Okay, let me tell you people over here that 0 is not a natural number. Natural numbers starts from 1. 0 is a whole number, but they are not talking about whole numbers. And what about integers? So we have integers. Positive integers starts from positive 1. Negative integers starts from minus 1. 0 is not an integer. So 0 comes in the category of whole numbers. And since all the whole numbers are rational, so we will write 0 in the category of rational numbers. And then comes 6.3. 6.3 is it's a terminating decimal, so we will write it over here in the category of rational numbers. It's also rational. And then we have the last number minus 10 upon 3. Although when we will divide minus 10 with 3, the answer would be minus 3.333333. That is a recurring decimal, but we know that it's a fraction, a recurring decimal. It's not non-recurring, non-terminating, and hence it would be also categorized under rational numbers. It's not an irrational numbers, right? So we are done with all the questions till question number 1 till 14 of exercise 1.3. I hope students the questions are clear to you. Still, if you have any questions, you can ask me in the comment section or you can contact me on my WhatsApp. So take care. Do subscribe to my channel if you are new. Don't forget to share it with your friends. Hit the like button. Take care. Allah Hafiz.